demonstrate a use case today that is very interesting for privacy-preserving data sharing with genomics data. Specifically, the idea of using randomization as a way to safeguard privacy. So in this case, Immuta has a policy known as a randomized response policy, which, if we know the full domain, is equivalent to local differential privacy. It fits the definition of local differential privacy. What this does is what randomized response or local DP does is essentially require that we randomly perturb some percentage of data and flip it to something else. So if you have, let's say, states, we would take some percentage of those states and flip them from one state to another. So California may be represented as Connecticut. Ohio may be represented as North Dakota. In this case, this makes it a really interesting case for genomics because the domain is relatively small. Really, we're looking at flipping to 2 to 3, maybe even 4 potential base pairs. But it's so that small domain really makes it nice to do this kind of analysis with randomized response. What this effectively does is give everyone in your data set plausible deniability. So let's say you have a rare marker for a disease. Some of those are going to be randomly flipped, and an observer won't know if that flipping, if what they're seeing is a result of a real value, or instead just a result of randomization. And there's some very interesting analysis that builds off of this, where you can use this to verify others' output and the output of other people's experiment through this randomization technique in a way that still preserves plausible deniability for everyone in the data set. So right now we have a policy applied to this data set where we are going to mask using randomized response the value of allele with a replacement rate of 30%. The idea here is that at that 30%, we're going to take 3 out of 10 at random values, patients in this case, and flip them from one determination to the other. So let me show you what this would look like. In this case, I'm using a marker for handedness. So if I run this query without the policy applied, you can see I have 17 instances of T for the allele and 31 instances of C. When I apply the randomized response, this makes this sort of makes the result more uniform. So here I will go, and this policy is applied. I'll run the query, and now this will be with that randomization still in place. And so my overall counts are still there. It's just now I have the randomization piece flipped into it. In fact, if I can look at the full data set here, and that randomization is still applied. I can even do a order by allele 1, and we'll see C's appearing at the top, followed by D's, and you have roughly those counts being well preserved. So this is a way that anyone in this data set has plausible deniability that they are left-handed versus right-handed in this case, or if it was a rare disease or a marker for something like cancer, now they are protected, and they have this level of protection that is tunable and still allows some downstream analytic results to come through. Thank you.